Yes. Oh, come on. Here's the thing. I was telling this story before. Everything is factorable. Is everything nicely factorable? No. This is, in the grand scheme of things, is this nicely factorable? Yes. So f of x here, what does f of x factor into? Oh, thank you. No, I wanted to know. Thank you. F of x, what does the top factor into? What do you factor out first? 4. Always take the easy. X squared plus 7x plus 12. And the bottom is, oh, what do we have to use here?
You have to group that.
Now, grouping is nice because here's the thing, everybody. Grouping is the only way you really have right now to do factoring cubics. So if I ever give you a cubic you have to factor, you can pretty much assume it's factorable. Okay, nicely factorable. We continue this. And do you notice I'm doing equal signs? I'm spacing my work out. I'm not just like throwing things at the board. X squared plus 3. No, it's not x squared. Everybody looks around, they're like, yeah, that's true. That's true. Over what?
Over
X squared minus, I think 9?
Yeah.
Is this right?
Yep.
Okay.
Yeah.
So can we still factor?
Yeah.
Yeah, because what do you have on the bottom? What's that called? The difference of squares. I'm liking the energy here. So it's x plus 3.
X minus 3.
And times x plus 2.
Yeah.
So what do you do now before you cancel? Domain.
X cannot equal -3 or 3 or -2.
Good. So now you what?
You cancel.
So let's cancel now. And I'll go to, I don't know, red here. And the x plus 3's cancel.
Yeah.
Right? So the whole is happening where?
At -3.
And where do you plug in -3 to get the y coordinate? Of the original simplified, right. Here's the simplified, guys. In the back, here we go, into the simplified. So we end up with 4 times -3 plus 4 over what? -6 times -1.
Yes.
So that turns into -3 comma, it's 6 on top. Or not 6, 4, right? 4 over 6, so which is? Okay, so we had that right originally, Sarah. So we'll go back and look at the limit in a second, Sarah. Okay? So what you can do, so let's go for now. What is our simplified form? We know f of x is, for some reason you guys just don't write down the simplified form. It's really weird. I don't know why that is. It's like, some of you do. What can you find now? You can find a lot of things. At this point, the order isn't super important, but what's one thing you can find? Intercepts? Okay.
Intercept.
So the x-intercept is when what?
Y equals 0.
So that's when 0 equals this, right? The numerator.
Yeah.
The only way to make a fraction equal to 0 is for the numerator to be 0.
Yeah.
So therefore, x has to be? -4. So that's we can plot that. That's right there, right?
Yes.
Do you agree?
Yes.
Okay. What can we find next? The y-intercept?
Yes.
X equals 0, so that's going to be 4 times 0 plus 4, -3, 2, right? It's just 0 minus. So what do you end up with? 16 over what?
16 over -6.
So it's -8/3.
Yes.
So 0 -8/3 is like -2 2/3. So it's like right about there. Is that correct?
Yeah. Yes.
Okay. What about the whole? Let's label the whole. Where is that? -3 2/3 is like right there. Can you see what I did there?
Yep.
Are we okay with the dots that I've written on the board?
Yes.
What's the 2 major things we haven't found yet?
Asymptote.
Yeah, so let's do the vertical. I'll make this big. Vertical asymptotes. Where are they going to be? X equals, look at, -2 and 3. X equals -2 and X equals 3. You have to write them as what? As X equals. The asymptotes are lines. You can't just say, it's like saying, like, what's a car? Tire. Like, you need a little bit more, okay? You need a little bit more. I know, it's so funny. Okay, so we have a vertical asymptote here. And where else do we have it? Is it at 3?
Yeah.
Okay, we have it at 3. What I like doing is I like labeling these. So we have x equals -2 and x equals 3. Something I still do all the time. I've literally had to make 3 or 4 versions of some of the videos you've watched because I'll get halfway through graphing something and realize I put the asymptote at like -3 instead of +3 and it makes you real sad. No. Okay. Is there a horizontal asymptote? You can find the horizontal asymptote before you do end behavior. The end behavior tells you how it approaches it, but you can find the horizontal asymptote by just looking at the leading terms. Look at the leading terms here. What do you have? 4x squared over x cubed. What of those two, what's the only one that quote unquote matters when x gets huge? X cubed, right? The x cubed gets huge, so the denominator gets huge. Do you agree? Yes. Huge. So that means that the horizontal asymptote is y equals 0. So I'm going to plug that in there. And I noticed at this point some people started getting a little sad here. So here's the horizontal asymptote, right? What's the thing here that made you a little consternated? You don't like that. Consternated, like you're frustrated, worried, not what you probably thought it was. Okay. Can you cross a horizontal asymptote?
Yeah.
You can. Listen, hold on. You can. Okay. Math teachers lie to you because sometimes you do. Hold on, I'll tell you why. You do things that you can't prove, for example, until you do later math. Here's an example. Here's the quadratic formula. You use it. To understand where the proof comes from, it's a little bit harder than when you start using it. In AP Calculus, we do a ton of stuff that I just say, this is true, and they're like, yeah, it's true. You need like second and third year college math to prove some of the things in calculus. Factoring, is everything factorable? Yes. Is everything factorable nicely? No. To explain to you as an Algebra 1 or Algebra 2 student imaginary numbers or irrational numbers or imaginary irrational numbers, no, no, right? You just say x plus 3 times x plus 2 is factorable, but anything else is ugly and therefore not factorable. In this case, you can cross the untruth that you're being told comes from vertical asymptotes. Can you cross vertical asymptotes? No. But can you cross horizontal asymptotes? Yes. It is possible. It is possible. Now, at this point, here's the thing. I want to ask you two questions at this point. Are there any other aspects of this graph we haven't found? Well, we found the domain first. We could do the end behaviors, but here's the thing. Don't let not knowing one thing kill the entire picture. What I mean by that is, absolutely, I know math, it's a subjective thing. Sometimes some things are easy for some people and harder for others. Don't let one thing that's hard to you kill the rest of it. Subjectively, I would just say, I think finding end behavior is, and most frequently is the hardest thing to find. Let's put together everything else and see if that helps us with end behavior, okay? Sophie noticed something. Are there any other x-intercepts? No. So what does that tell you about the middle here? It has to go down, right? It can't go up, because if it goes up, it'll cross the horizontal asymptote. Are there any other intercepts other than that one? No. I'm going to give you another kind of cheat code here. Look at the simplified form. You see the simplified form right here, everybody? What's the degree of this term right there? What's the degree? 1. What's the degree of this one?
1.
Both of those numbers are odd, okay? Here's something that's super helpful, okay? Which asymptote, everybody, which asymptote is created by this? X equals 3. If, vertical asymptote, yes. If the degree is odd, the arrows have to go in opposite directions. So look, we definitively know. Listen, I'm giving you good stuff here. You already suspected it. Look, you already suspected it because the point is up here, right?
Yes.
Well, we know this has to go down because it can't cross the x-axis, right?
Yes.
So what does this have to do? Has to go up. So we know, Anna, breathe.
So Mr. Seamon, say theoretically.
So therefore, if that one goes down, what does the other one have to do? This has to go up. Now, are there any other places where it crosses the x-axis?
No.
So this is just going to keep on getting closer to 0, right?
Yeah.
Here's the thing that caused you a little bit of grief here, right? It crossed here, right?
Yeah.
But does it still approach the x-axis? So here's what it does, everybody. It goes below for a little while, and then what happens? It goes back up. Yeah. Now, it goes back up to 0, but does it cross it? No. There's one. This is the last question I'll ask you, and then I'll let you leave. There's one last point on here that we haven't labeled yet that would be really interesting to find. What's the one point on here we haven't labeled yet? Take a look. We have an intercept, we have a hole, we have like this thing, something over here. What would be nice to know right here?
The lowest point.
Exactly.
Whoa.
We don't do that in this class yet. Finding this point is a little challenging, but the point is, it does cross, right? But we know it has to go back to 0, but it can't cross it, so it's going to go down and back up. You need derivatives, and you need a little bit more calculus to find this point. It can cross. How many times can you cross a vertical asymptote? As many as you want, actually. You can make it, do it as many times as you want.
The horizontal.
Get out of here. Horizontal.
Are we going to learn how to find this point?